In this video, we're going to determine the vertex, a maximum or minimum, on the calculator. In the very last video, we had a formula. Remember, x equals negative b over 2a, in order to find the vertex, the coordinate points, the x value actually, of the vertex by hand. A lot of times it's very useful, but this is another way to find the vertex, and we will need this process later when we get to problems that do not have a formula to find the vertex. This is a parabola. Now look at this curve. This is a quartic. It's a fourth power, and if you'll notice, I've got it bottoms out here. It's a minimum. Tops out here, that's a maximum, and it bottoms out here, another minimum. And I don't have a formula to help me find where it is bottoming or topping out. So I've got to rely on the calculator to find this, or find those particular points for this type of graph. So we're going to learn the process now, so when these problems come up later, we'll already know how to do it. So let me take that down. So my example here, I've got a parabola, f of x equals x squared minus 7x plus 6. So you need to go to the y equals screen and type it in and press graph. So let me go ahead and do that on here. Let me clear that off. I'll move this one over. So I've got x squared minus 7x plus 6. And there's my picture. Now, in order for me to get any information off the graph, off of my calculator, I have got to do the next step. When I do second trace, I'm going for the calc menu. Notice the color coordination here. And if I do second trace, I have the very same window that I reproduced here. Now, if you'll notice, I've indicated minimum. Well, remember about a parabola. This one is concaved up. My a value is a positive 1, so it's concaved up, which means my y value here will be the smallest y value on this whole graph. That's why it's called a minimum. Now, if my parabola had been concave down, then I would have had a max. So you do have to know the difference between min and max. So let me go ahead and I'll look at these steps, and then we'll do it on the calculator here in just a second. I hit 3. Now you could cursor down, but the numbers are here for you to go ahead and press depending on what you need. It's a quick way to get there. Then it says you choose an x value to the left of the vertex and hit enter, or press enter. Then choose an x value to the right of the vertex and press enter. Then you hit enter again. There's no need to guess because you're already, what it does is it starts setting up blinders. So in this particular screenshot, I pressed 2 and hit enter, and this little symbol right here, that little triangle, appears. Now when I go and now it's asking for right bound, so I pressed in a 6. This thing occurred. So if you'll notice, if you could just look between those two arrows like blinders, if you'll notice, I've got where it bottoms out cornered in there. And I said there, you hit, go ahead and hit enter again. There's no need to guess. When it asks you to guess, and you should have the word min or max. And the little cursor should be blinking on what you've got there. So let me get my calculator up. So I'm going to press number 3. It's asking for a left bound. Now remember, this is where you choose an x value. So it looks like my vertex is right in here between 3 and 4. So instead of pressing 2 or doing 2 like I did earlier, I'm going to press 2.5 because I want to be different. And then I hit enter, and that little blinder thing will come up. Notice I've got a boundary on the left right here. Now I need to get a right boundary, so let me press, we'll do this one, which is 5. Hit enter. Now if you'll notice, my boundaries have got this where the vertex They've got it cornered. It's inside that. Guess? Nope. Just hit enter. If you'll notice, when I use different values, I come up with a little bit different x. You need to round a little bit, but guys, 3.5 is my min, and if you use your Vertex formula, you'll come up with that. My y value is negative 6.25. I wish that this word minimum would be right here at the y value. The x value is not the minimum. The x value is the location. I've got a minimum of negative 6.25. So now here's the keystrokes that I had to go through, and there's not that many to get me all the way over here. Now we had a problem in the last video. Let's see if we can do it, because it's a little bit different. We've already found the vertex. Let me move it up a little bit. Let's see, the last video, let me get my paper. Where was it? Oh, here it is. Negative x squared plus 2x plus 4. Negative coefficient, it should be concave down, so let's see. There it is. Notice this y value right here is a maximum. So now let's go. I've got second trace for the calc menu, number 4. Now it looks like this thing's around 1. Now right now this is to the left, so I can go ahead and press enter. Let's put in a number to the right of it. Looks like 1, so I'll put in 2. You could get further apart if you want. The biggest thing is that these boundary values have to have your vertex in this particular situation cornered. Guess? No, just hit enter and you should have this word, maximum. Now my maximum value is y equals 5. Okay? The x is only the location. I could say this, at x equals 1, my maximum is y equals 5, or just 5. That's how I could do that. So now you need to go and play with some problems maybe that you've already done, but you need to get very good at this, because like I said, we're going to have problems that's going to have maximums and minimums on the same graph. I have no formula to get them, so I've got to be able to use my calculator. Okay? Talk to you later. Bye-bye.